In this episode, we take the supervision idea and focus it on three outcomes that matter even when a model seems to be working: fairness, safety, and quality. These are not buzzwords, and they are not optional extras, because they describe whether an AI system treats people appropriately, avoids causing harm, and delivers results that are dependable enough to be used in real decisions. For brand new learners, it helps to imagine a school grading policy that is accurate for most students, but consistently unfair to a few, or a safety rule that works most of the time, but fails in rare situations where the consequence is severe. An AI system can look strong on an average performance metric while still creating unfair impact patterns, unsafe outcomes, or quality failures that customers notice first through frustration, harm, or mistrust. Validating supervision means verifying that the organization is not only watching outputs for obvious mistakes, but is actively monitoring and responding to signals that fairness, safety, and quality are drifting out of acceptable bounds. This is a major step beyond simple monitoring because it asks whether the supervision system itself is adequate for these outcomes, not just whether the model has a dashboard. The goal is to understand what fairness, safety, and quality mean in operational terms, how organizations supervise these impacts over time, and what evidence shows that supervision is working. By the end, you should be able to explain how an evaluator validates that supervision covers these areas without turning supervision into noise or empty promises. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Fairness is often misunderstood by beginners as meaning everyone gets the exact same outcome, but in responsible governance, fairness is more about consistent, justified treatment that does not create inappropriate disadvantage for certain people or groups. An AI system can be unfair even when it is statistically accurate, because it may make more errors for one group than another, or it may rely on signals that act as proxies for sensitive attributes. Validating supervision of fairness impact begins with defining what fairness means for the use case, because fairness expectations vary across contexts, policies, and decision types. The organization must decide what patterns would indicate unfair harm, such as large differences in error rates, different denial rates without justification, or different levels of access to remedies and review. An evaluator then asks whether supervision includes metrics and review processes that can actually detect these patterns over time. This includes looking at fairness across segments, because averages can hide disparities, and it includes checking whether fairness signals are reviewed by people with authority to act. For beginners, fairness supervision is like a teacher regularly checking whether grading is consistent across classes and assignments, not waiting for students to complain. If the organization cannot show that it looks for unfair patterns proactively, it is not supervising fairness. It is hoping fairness happens. To supervise fairness effectively, the organization needs thoughtful segmentation, but segmentation must be handled carefully because it can involve sensitive data. Sometimes fairness analysis uses protected or sensitive group categories in controlled environments to detect disparities, while ensuring that these categories are not used to drive decisions inappropriately. In other situations, the organization may use indirect segmentation, like geography, product type, or channel, to detect patterns without directly using sensitive attributes. The evaluator's task is to validate that the organization has a method that is appropriate for its policies and that it produces meaningful insight rather than vague reassurance. Fairness supervision should also include an escalation pathway, because detecting disparity is not enough. Someone must decide what it means and what to do about it. This might involve adjusting thresholds, adding human review for certain decisions, improving data quality, or narrowing the model's scope until risks are mitigated. Beginners should understand that fairness issues often emerge gradually, so supervision must be periodic and consistent rather than occasional and reactive. When customers discover fairness harm first, it often means the organization was not measuring the right segments or was ignoring signals that were already visible. Valid supervision turns fairness from a claim into an ongoing control process. Safety supervision focuses on preventing outcomes that could cause physical, financial, or psychological harm, and it is especially important when a system influences high-impact decisions or provides guidance that people might follow. Safety is not only about the model being wrong, it is about the model being wrong in a way that hurts someone. This means safety supervision must emphasize high-severity failure modes, even if they are rare, because rare harms can still be unacceptable when consequences are severe. For beginners, it helps to compare this to airplane safety, where rare failures are treated with extreme seriousness because the impact is catastrophic. Validating safety supervision involves checking whether the organization identified credible harm scenarios, designed signals to detect early warning signs, and created triggers that force human review or system limitation when risk rises. Safety signals can include spikes in certain kinds of risky recommendations, increases in severe complaints, patterns of overconfident errors, or evidence that users are misinterpreting outputs as guarantees. The evaluator checks whether these signals are monitored, whether thresholds are defined, and whether teams can intervene quickly through controls like routing to human review, disabling certain outputs, or pausing automation. Safety supervision is credible when it is designed around worst-case harm, not just average behavior. A subtle safety risk is that a system can be safe in isolation but unsafe in the workflow it sits inside, because downstream actions can amplify small errors into large harm. For example, a model might score risk, but if the workflow treats a score as a final decision without review, then the model's uncertainty becomes a safety risk. Validating safety supervision, therefore, includes examining how outputs are used and whether safeguards exist to prevent over-reliance, especially in high-impact decisions. It also includes checking whether users understand limitations, because misunderstanding can create harm even when outputs are technically reasonable. For beginners, this is like a medication label that must include clear warnings, because misuse can harm patients even when the medication is effective. An evaluator will look for evidence that safety supervision includes training, communication, and clear escalation rules, not only numeric monitoring. They will also validate that the organization can respond to safety incidents with speed and documentation, because safety risk requires urgent action. If safety supervision exists only as a dashboard and not as a response capability, it is incomplete. True safety supervision means detection and intervention are both real. Quality supervision is often confused with accuracy, but quality is broader and includes consistency, usefulness, and reliability of outputs within the context of the business process. A system can be accurate in a narrow technical sense, yet still be low quality if it produces outputs that are confusing, inconsistent, or unhelpful for the people using them. Quality also includes operational aspects, such as whether the system behaves predictably under normal load, whether it handles missing data gracefully, and whether its outputs maintain a stable meaning over time. Validating supervision of quality means verifying that the organization monitors indicators that reflect real use, such as rates of manual override, reviewer disagreement, customer follow-up, repeated contacts, or downstream rework caused by poor recommendations. For beginners, quality supervision is like a restaurant checking not only whether meals are cooked correctly, but whether customers actually enjoy them, whether the experience is consistent, and whether mistakes are caught before food leaves the kitchen. An evaluator checks whether the organization defined what quality means for the use case and whether it is supervising that definition with evidence. Quality supervision also matters because quality degradation often precedes larger failures. When quality slips, trust erodes, and safety and fairness issues become harder to manage. A mature supervision program treats quality as an early signal, not as an afterthought. Validating supervision across fairness, safety, and quality requires looking at the structure of supervision itself, because supervision can fail even when monitoring metrics exist. One common failure is lack of ownership, where metrics are collected but no one is accountable for reviewing them and acting on them. Another failure is lack of cadence, where reviews happen only when someone remembers or when a crisis hits. A third failure is lack of thresholds, where people see trends but cannot agree on what counts as unacceptable, so action is delayed. An evaluator validates supervision by checking whether each metric and signal has an owner, a review schedule, defined thresholds, and a documented action plan when thresholds are crossed. For beginners, this is like having a school policy about bullying, but no staff assigned to enforce it and no process for responding to reports. Supervision must be designed as an operating system for risk, not as a collection of data points. If supervision lacks clear action pathways, the organization will still be surprised by customer harm even though numbers were available. Validation is about proving the operating system exists and works. Another essential part of validation is ensuring the organization uses multiple signals rather than relying on a single metric, because fairness, safety, and quality are multidimensional. A single metric can be gamed or can hide problems, such as a drop in complaints that actually reflects customer resignation rather than improvement. A robust supervision approach uses a combination of leading indicators and lagging indicators, where leading indicators warn of rising risk and lagging indicators confirm impact after the fact. For example, rising reviewer disagreement can be a leading indicator, while verified incidents are a lagging indicator, and both matter. For beginners, it helps to see leading indicators as the first signs of illness and lagging indicators as the diagnosis. You want both, but you would rather treat early when possible. An evaluator will ask whether the organization's signals are balanced and whether they cover both individual case harm and pattern harm. They will also check whether signal definitions are stable and versioned, because if definitions change, trend comparisons can become misleading. Valid supervision is measurable over time only when measures are consistent and changes are documented. Validation also involves testing whether supervision catches known problems, which is an evaluator's way of avoiding blind trust in the supervision system. If the organization has had incidents or known failure modes, the evaluator will ask whether supervision detected them quickly and whether actions were taken. Even in the absence of major incidents, the evaluator may examine whether supervision would detect plausible failure scenarios, such as drift in a high-risk segment or a sudden change in denial rates. For beginners, this is like a fire drill. You do not wait for a real fire to find out whether your alarm system and evacuation plan work. The evaluator looks for evidence that the organization has rehearsed escalation, tested alerting, and verified that people respond appropriately when triggers fire. They also look for whether supervision includes documentation of decisions, because documentation proves that supervision led to action rather than discussion. If supervision cannot be demonstrated through past detections or tested scenarios, it may be theoretical. Validation is the process of turning theory into demonstrated capability. A common beginner misunderstanding is thinking fairness, safety, and quality are separate silos, when in practice they interact. A quality problem, like increasing error in a certain category, can become a fairness problem if the category overlaps with a particular group. A safety measure, like tightening thresholds to avoid dangerous outputs, can become a quality problem if it creates too many false alarms and overwhelms reviewers. Fairness adjustments can change operational workload and affect quality if the organization does not plan for the impact. Validating supervision means checking not only each area individually, but also how the organization manages trade-offs and avoids solving one problem by creating another. For beginners, this is like adjusting classroom rules. A rule that reduces cheating might increase anxiety if applied harshly, so you supervise how the rule affects the whole environment. A mature supervision program includes cross-functional review where trade-offs are discussed openly and decisions are documented. It also includes the ability to narrow scope, add human review, or pause automation when trade-offs become unacceptable. Validation requires evidence that the organization can manage these interactions responsibly. To make this practical, imagine an AI system that helps decide which service requests should be prioritized first. Quality supervision might detect that the system is increasingly misclassifying complex cases, leading to more rework and longer resolution times. Fairness supervision might detect that a certain region or customer type is consistently receiving lower priority, not because of real need differences, but because of data patterns that act as proxies for sensitive factors. Safety supervision might detect that certain urgent requests, like safety-related complaints, are occasionally being deprioritized, which is unacceptable even if rare. A validated supervision program would have signals for each area, thresholds that trigger escalation, and a process for intervention, such as routing certain categories to human review or adjusting decision rules with controlled change management. It would also document why these actions were taken and monitor whether interventions improved outcomes without creating new harm. The point is that supervision is not a passive scoreboard. It is an active safety net that must catch issues across multiple dimensions. When it works, customers are less likely to be the first ones to notice harm because the organization sees the patterns earlier and responds. When you step back, validating supervision of AI impacts on fairness, safety, and quality means proving that the organization has ongoing, evidence-based control over how its system affects people and outcomes. It requires clear definitions of what fairness, safety, and quality mean in the specific use case, meaningful signals that can detect both individual harm and harmful patterns, and structured ownership, cadence, thresholds, and action pathways that turn detection into intervention. It also requires multi-signal thinking, because these outcomes cannot be captured by one number, and it requires attention to trade-offs because improvements in one dimension can create risk in another. For brand new learners, the central takeaway is that supervision is only credible when it is validated, meaning the organization can show that it detects issues early, escalates appropriately, and adjusts the system responsibly over time. Fairness, safety, and quality are the outcomes customers experience, so supervising them is how the organization protects trust before customers are forced to raise the alarm. When you can explain how supervision is validated across these dimensions, you demonstrate the domain 2D capability to evaluate whether oversight is real, effective, and ready for real-world complexity.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.